So now coming to the unit vector. So when we talk about unit vectors, so what is the first thing which comes into our mind? It's I cap, j cap, k cap. அது மூணு வெக்டர் தான் நம்மளுக்கு கரெக்டாக ஞாபகம் வரும், ரைட்? யூனிட் வெக்டர் சொல்லும்போது. ஆனால் யூனிட் வெக்டர் கேன் பி இன் எனி டைரக்ஷன் யூ வாண்ட். It need not be in the x, y, z axis itself. Okay, it can be in any way you want. So if I am going to say this as OP vector, or simply I will just take this as R vector. Okay, so since we have got to this point, so I will just call this as R vector. Now this R vector is having a direction, it is having a magnitude also. If I am going to take a magnitude of 1, then that is called as R cap without changing the direction. If I am going to take only magnitude 1, so that will be called as R cap. Okay, so basically how many R caps do we need to get R vector? That is the magnitude of the vector. Okay, so R vector is going to be equal to modulus of R vector dot R cap. Okay, this is going to be applied for any dimension. Okay, so here R cap is a unit vector in the direction of R vector. Okay, so it is going to have a magnitude of 1. Okay, 1 unit. Okay, so the modulus of R vector is the magnitude of R vector. Okay, or basically how many R cap do I need to get R vector? Okay, you can take it in that way. Okay, okay, so these are the fundamental things. So coming to the so previously we saw what was OR vector. So if R is given as xyz, if R is given as xyz, then you can also represent R vector as, so we already know what is x. X is going to be written as, no, x is going to be written as cos alpha into modulus of R vector, basically the length of this vector, right? So we can also represent R vector now in this form, modulus of R vector dot cos alpha I cap plus modulus of R vector cos beta j cap plus modulus of R vector cos gamma k cap. Okay, so in that case what can I say? R vector, so I will just take it to the other side, modulus of R vector, we can just take it as a common factor outside. Since it is a scalar, we can just take it outside as a common factor. So what do we have inside? Cos alpha I cap plus cos beta j cap plus cos gamma k cap. Okay, now we can just compare it. So what is R cap? Yes, so this vector is going to represent R cap. Okay, so for any vector R, this is going to be R cap. So so make a note of this. This is going to be R cap. Okay, now as we already saw, R cap is going to have a magnitude of 1. R cap magnitude 1 abdina, what can you say about this magnitude of this? What is the expression we get? Cos square alpha plus cos square beta plus cos square gamma equals 1. Okay, So vector algebra is very important. These things will be really useful, not just for solving 3-dimensional geometry, it will be useful for solving 2-dimensional also. Okay, though we don't use in 2 dimension, but still we can use at some places. Okay, in 2-dimensional also. So from here we are having the important result that cos square alpha plus cos square beta plus cos square gamma equals 1. Okay, because since modulus of r cap equals 1. Okay, and from this result you can also get, so given the vector you know how to find the unit vector. How do we find? We divide it by the modulus of the vector to find the unit vector, and from there you will get a relationship between the direction ratio and the direction cosines. Okay, what is L then? L will be equal to A by root of a square plus b square plus c square, where ABC is the direction ratio. And what is root of a square plus b square plus c square? Magnitude of that vector. Okay, that's how it goes. Vector addition. So let us take a reference point O. So let it be OP vector, or you can just simply write it as A vector. Okay, A vector, and this will be B vector. So there is a question now, what is A vector plus B vector? What is the geometrical representation of A vector plus B vector? So what do we do here is, since it is a free vector in the sense we can move it anywhere, so you consider this as A vector, so we are just going to move it, and A vector plus B vector is going to be represented as the diagonal being formed by the parallelogram. Okay, so we have A vector plus B vector. Okay, so this is basically the diagonal being formed. Okay, and you know how this will apply, right? So there are many physical applications for this. Okay, now say for example the vectors are having an angle of alpha, they are subtending some angle alpha. Okay, they are subtending some angle alpha. We need to find the length of this. So how do you find the length of this? The length of this is the magnitude of A vector plus B vector. How do you find the length of it? Of course we have a formula. We use the cos law, basically the cosine rule. So if this is alpha, I can just write this as pi minus alpha. So if anyone not knowing cosine rule, just make a note of it. Okay, I am just writing that. So here we can actually use the cosine rule. Given the adjacent sides, we need to find the opposite. So pi minus alpha, so cos of pi minus alpha can be given as a square plus b square, a square plus b square minus, I will just take this as r. Okay, take it as r. So if I am going to take this as r vector, so I can just write a square plus b square minus r square divided by 2 times of a into b. Okay, now cos of pi minus alpha, it's going to give me minus cos alpha. Okay, So this is what you called as cos law, cosine rule. This is the cosine rule of triangles. Okay, square, just find the sum of squares of the opposite sides which is containing the angle minus the square of the side which is facing the angle divided by the product of the sides containing the angle, 2 times the product of the sides containing the angle. Now what do we have? R square is equal to, so after rearranging, a square plus b square plus okay. Now there are some properties you need to know. Most of the properties we know already. Properties of addition, whatever applies for numbers will also apply for this. That I saw. Now, so we have a very important rule, modulus of a vector plus b vector. Okay, modulus of a vector plus b vector. So in the diagram if you take the sum of a vector plus b vector, we get this. So this is, if you take the magnitude of this, whether it will be greater than the sum of these two or less than the sum of these two. Less than, right? It's going to be less than the sum of these two, and you can just put equal to. You can put equal to when both of the vectors are same. Okay. So a vector plus b vector, modulus of a vector plus b vector is less than or equal to modulus of a vector plus modulus of b vector. Okay, this is a very important, the triangle inequality. Okay, so this is the triangle inequality. So what about modulus of a vector minus b vector? Any idea? What will be modulus of a vector minus b vector? இப்போ ப்ளஸ்க்கு பதிலாக இங்கே மைனஸ் போட்டோம்னா மாடுலஸ் ஆஃப் மைனஸ் பி வெக்டர் வரும். இது எப்படி லெஸ் தேன் வருது? This is triangle inequality. Basically in a triangle we have 3 sides. Sum of any 2 sides will be greater than the third side, right? For a triangle I am saying sum of any 2 sides will be greater than the third side, because these are 2 sides of a triangle. The sum of the 2 sides will be greater than the third side. அது என்ன combination of 2 எடுத்தாலும் அப்படி தான் வரும். Okay, that is a property of a triangle. If both are equal, then we can just say 2 times of a vector is equal to 2 times of modulus of 2 times of a vector is 2 times of modulus of a vector. We can say that, right? Okay, I will just write that also. So k times of a vector, okay, modulus of k times of a vector is going to be k times of the magnitude of a vector. So in that case we can just put a equal to b கொடுத்தோம் அப்படினா modulus of 2a vector will be equal to 2 times of modulus of a vector. எது ரெண்டும் ஈக்குவலா இருந்தா ab less than or equal to b. So equal to angle, equal to angle, என்ன angle a vector equal to b vector இருந்தா. So in that case you are asking if a vector was equal to b vector. Okay, you are asking like modulus of a vector plus b vector equal to modulus of a vector plus modulus of b vector இருந்தா என்ன angle இருக்கும்? 0 தான் இருக்கும். Because you can say, right, a vector plus b vector, a vector b vector, and மூணு வெக்டரும் coincident. That's all about this. And also all the properties of the numbers will hold for here also. Commutativity, associativity, all the things.
So modulus of a minus b is also the same, right?
Modulus, it's going to be greater than or equal to modulus of a vector minus modulus of b vector. Okay, I have to write that. This is not a very special law and all, it comes directly from there only. Okay. Yes, any doubt? இதிலிருந்து தான் இது வருது. Okay, don't get confused with this is a separate law. No, it's not a separate law. You put in the place of a vector minus b vector. This will be a vector minus b vector. Here b and minus b gets cancelled. A vector மட்டும் இங்க இருக்கும். You take it to the other side. Modulus of a vector minus b vector less than or equal to modulus of a minus b. Okay. So if you let a vector to be a vector minus b vector in that above result, in this result if you let like that, you will get to this. Okay. Okay, can we go for the questions? So I guess everything is completed, right? Unit vectors, position vectors, how to write a vector with respect to two different points. If you are given two different points, how to form a vector, the final minus initial logic, those things, these laws, the addition laws. Of course we have many laws to do. We have the product, scalar product, vector product, scalar triple product, vector triple product, many things are there. We will do it. But usually in this session and in the next session, in this session we will just look at the applications of vector addition. In the next session we will be looking at collinearity also in detail. Collinearity, parallelism, coincidence, those things. அதிலிருந்து வந்துட்டு you can get many types of questions basically. Okay, you will be getting many types of question based on those things. So I think everyone know force is a vector, right? So ABCDE is a pentagon. Prove that the resultant of the forces is 3 times of AC vector. Okay, so these are the forces. Is there a possibility to draw a pentagon? No, we can only draw only a hexagon can be drawn. Okay. Oh, okay. So let us take a pentagon. Okay. So I hope everyone knows a pentagon has 2 symmetries. So AB vector, so AB vector na ninga eppadi vandu direct பண்ணுவீங்க, like how the direction should be, it should be like this, starting A to B, like that. Okay, so this is AB vector. AE vector, so it should be like this, AE vector, BC vector, DC vector, final initial, like that. Okay, ED vector and AC vector. So we have AC vector over here. So they are asking you to prove that the resultant of these forces, AB vector, resultant na addition basically. Okay, so we just have to prove AB vector plus AE vector plus BC vector plus DC vector plus ED vector plus AC vector equals 3 times of AC vector. So we need to prove this. So can you see that AB vector plus BC vector is equal to AC vector. That can be seen easily, right? AB vector plus BC vector equals AC vector. So we can just add these two, AB vector and BC vector. So that accounts for one AC vector. Okay. இப்போ AE vector and CD vector, they are not related to each other, but whatever you are doing for triangles will be applied for any shape. Okay. So இங்க நம்ம என்ன சொல்லலாம், உங்களுக்கு வந்து என்ன தெரியணும் அப்படின்னா அந்த terminal initial point must be same, that's all. Okay. So இப்போ இங்க we are actually like AC CD DE. Okay. So AE vector can be written as AC plus CD plus ED, AC plus CD plus, okay, ED is minus, okay. So we need a minus sign over here. Okay. Anyway, we'll just write it. Okay, we'll just write a equation. Okay, we'll just write a equation. AC vector oh yes, ED is downward, yes. Then we can add DC, yes. And then it is done, right? So AC vector is going to be AE plus ED plus CD, yes. AE vector plus ED vector plus DC vector equal to AC vector. So inga AE, DC, ED. So all these three are going to be cancelled out for one AC vector. Okay. So AC plus AC plus AC, 3AC. Okay. That's all. And yes, again we need to be really careful over here. So இந்த law வந்துட்டு நீங்க எந்த ஷேப் வேணாலும் யூஸ் பண்ணலாம். ஆனா ஒரு விஷயம் மட்டும் நல்லா ஞாபகம் வச்சுக்கோங்க, இனிஷியல் பாயிண்ட் ஃபைனல் பாயிண்ட் அது மட்டும் வந்துட்டு நீங்க பார்த்துக்கணும். ஓகே. அதுக்கப்புறம் டைரக்ஷன். Okay. So it's like you're going to start from here and you're going to end from here, end to this, and that is same as starting from here, ending here. Though it is not same in magnitude, in vector addition it is same. Okay. So keep that in your mind. Prove that the sum of three vectors determined by the medians of a triangle directed from the vertices is 0. So whatever we are proving it, we just you just take it as a result also. Okay, it will be useful sometime later. Is it possible? Of course, it's not necessarily an equilateral triangle. So everyone knows what is a median, right? Median means what? From a vertex to the opposite side of midpoint of the opposite side. Okay, that forms one median. Okay, here also. Okay. Now prove that the sum of three vectors determined by the medians of a triangle directed from the vertices. So we'll just name the vertex as A, B, C, and these points E, F G. Okay. Now is there any relation between the sides and the median here in terms of vector? Is there any relation between the sides and the median? So say for example you take AC, BC and CG. Is there any relation you can get? Concurrent. Concurrent, yes. In terms of vectors. CA plus CB is equal to CG. So it's not that CA vector. Okay, we will just make the vectors first. Okay. So here we are having AB vector. Okay. AC vector, CB vector. Okay. And here we are having we can take it in this way. Okay. So because A is the reference point, so EB vector, AF vector and CG vector. Okay. Now is there a relationship between AC, BC and CG? The opposite. Directed towards. Okay. But we are writing everything in terms of A, right? Okay. Anyway, we just change it. Okay. So say for example, you just make a parallelogram. Okay, make a parallelogram. Okay, with these two sides, make a parallelogram. Okay, what happens? So if you make a parallelogram, okay, the way I am drawing. So say for example, this is my triangle. This is my triangle. If you want to make a parallelogram, the median is going to pass through the other vertex of the parallelogram. Correct? The median of this side is going to pass through the other vertex of the parallelogram. Why? Because the diagonals are bisecting. The diagonals bisect. Okay, these two are going to bisect each other. Don't look at this diagram. Okay, this is not really accurate, but this is a fact we already know. The diagonals are going to bisect each other. So if you form a parallelogram with these two sides over here, then this median, you can take this as the resultant of these two vectors. Okay, but since we are having only half of it, we can simply say that 2 times of this vector is going to be CA vector plus CB vector. Okay, can we say that? Asara purida. இப்போ இது வந்து A vector எடுத்துக்கோங்க. ஓகே, இது A vector எடுத்துக்கோங்க, இது B vector எடுத்துக்கோங்க. இப்போ இது என்னது? It will be R vector. So what about this portion, like what about this portion? It will be r vector by 2 because it is getting bisected, diagonals are bisected, so this will be only half of it. Okay, area wo half da, area of a triangle is half of the parallelogram, but that is not over here. That's not what I am talking about. I am just talking about the length of this resultant vector, that is the diagonal of this parallelogram, and we already know diagonals are going to bisect each other, so that means this is also going to bisect, and this is the midpoint. Basically bisect பண்ணதுனா இந்த சைடோட midpoint அது. Okay, இந்த பாயிண்ட் தான் வந்து இந்த சைடோட midpoint. இப்போ நீங்க அதே லாஜிக்கை ட்ரையாங்கிள்ல பாருங்க சொல்றேன். அப்ப நீங்க ரிசல்டன்ட் வெக்டர்ல இருந்து பாதி தான் எடுக்கிறீங்க. This is half of the resultant vector. Okay, so what can I say here? Here I can say, okay, the way the direction, I'll just change the direction. So take it like CA. Okay, CA vector, CB vector, the resultant is going to give me CG vector. Okay, so CA vector plus CB vector is going to give me the resultant. That resultant you can say it is 2 times of CG vector. Can you get the point? 2 times of CG vector. So okay, 2 times of CG vector. triangle ரெண்டா பிரிக்கலாம் அப்படினா like okay,
so AG plus AB வந்து AG plus GB வந்து ABC,
AG plus GB AB. Okay,
நான் சைக்கிள் ப்ராப்பர்ட்டி வச்சு ரெண்டு ஈக்குவேஷன் உள்ள ஆட் பண்ணிக்கலாம். AGC BGC ரெண்டு சைக்கிள் ப்ராப்பர்ட்டி
AGC and BGC.
சார் அப்ப GB அப்படியே AG கிடைக்கும் சார். அடுத்து அதுல AB போடுறோம் சார். நாம இதெல்லாம் பிரைமரி
So what are the system of equations we will be getting then? So okay, bisect பண்ணியாச்சு அப்படினா நான் எனக்கு என்னென்ன கிடைக்கும், like okay, AC plus CG
equal to AG.
okay, fine, AC plus CG equal to AG. okay, அதே மாதிரி
CB plus CG
CB plus CG. How do you say, like CB plus CG, you cannot add them, right? BC plus CG, BC vector plus CG vector, yes, BC plus CG is going to give me GB vector. So when we add both of them we get AB vector. Okay, so AC vector plus BC vector plus 2 times of CG vector equal to AB vector. So AC vector plus BC vector. Okay, now we are having, okay, AB vector I can write this as AC vector plus CB vector. You can cancel out AC here. I think we are just coming to the same point, right? So you can write 2 CG vector as AB vector, no, No, we're not getting anywhere, right? No, but there are three vectors are getting involved, right? Now actually what we did here is only two sides were involved here, but here we are having three sides involved. But anyway, if AC plus CB, so we are having AC plus CB as AB vector, but we have also got AC plus BC plus 2 times of CG. So if you cancel out AC and AC over there, what do you get? 2 times of CG vector equal to CB vector.
Those three vectors like y.
Which vectors?
Those three median vectors.
We extend those three median vectors.
Like this and this, and then the certain problem.
If there are any two medians, then it will be opposite of the third median.
How opposite of the third median? Okay. Did you get any result out of this? No. Actually separator பண்ணும்போது I don't think we are getting something from there. We cannot do it separately. See, இப்போ நம்ம separator பண்றோம் அப்படினா the point that CG is a median, that itself is getting lost, right? You think in it that way. We are talking about a median of some triangle, and if you divide this into two parts, that median is lost, right? Now we are not talking about a median. Median of one triangle பத்தி தான பேசுறோம். நம்ம மீடியன் யூஸ் பண்ணி ரெண்டா பிரிச்சிட்டோம், ரெண்டு ட்ரையாங்கிள் கொண்டு வந்துட்டோம்னா no man, that is not working. That will not work. Wait. Okay. So I think this is clear, right? This fact is clear. This fact is clear. இப்போ இதே மாதிரி நம்ம எல்லாத்துக்கும் பண்ணலாம். So what about AF vector? What about AF vector? AC vector plus AB vector equal to 2 times of AF vector. அதே மாதிரி BE vector, what about BE vector? 2 times of BE vector is going to be, so you can have BC vector plus BA vector. Two times of BE vector. So if you add all of them, can you get 0? Everything, add all of them, you get 0. Right? So CA and AC is going to get cancelled if you add. CB and BA is also going to get cancelled. AB BA is also going to get cancelled. Yes. BC and CB gets cancelled. Okay. And it's not about the direction, because like நீங்க எப்படி வேணாலும் டைரக்ட் பண்ணலாம். Okay, that is what I was saying from the start. You can direct it in any way you want. இப்போ நீங்க இந்த மாதிரி டைரக்ட் பண்றீங்க அப்படினா நோட் பண்ணிக்கோங்க இத. Just keep it in your mind. இப்போ நீங்க இப்படி டைரக்ட் பண்றீங்க அப்படினா it is BA vector. Okay, இப்போ இதே மாதிரி நான் வந்து இத அழிச்சிட்டு நான் திரும்ப இப்படி பண்றேன் அப்படினா I am just putting a direction like this அப்படினா that will be AB vector. Okay, okay, BA vector, yes. So this is going to be AB vector, and if you're going to direct like this, it's going to be BA vector. Okay, that's all. So basically the final and the initial point. Okay, நீங்க எப்படி வேணாலும் இத டைரக்ட் பண்ணிக்கலாம். Okay.